Hello all, welcome to my channel Math Made Easy. In the previous videos I solved section C question number 27 and 28. In this video we are going to start with question number 29. Let's see, if cos theta plus sin theta is equal to 1, then we need to prove that cos theta minus sin theta is equal to plus or minus 1. Since we need to prove cos theta minus sin theta is equal to plus or minus 1, see, we know that if x square is equal to 1, x will be square root of 1, which is plus or minus 1, right? So now if we had, since we have to prove cos theta minus sin theta is equal to plus or minus 1, if from the given data, if we get this relation cos theta minus sin theta whole square is equal to 1, then we'll get cos theta minus sin theta is equal to root 1. So root 1 is plus or minus 1, right? Then we'll get a result. So somehow by using the given data cos theta plus sin theta is equal to 1, we need to get cos theta minus sin theta whole square is equal to 1. Okay, let's see. We have cos theta plus sin theta is equal to 1. So square on both sides. By squaring on both sides, we get cos theta plus sin theta whole square is equal to 1 square, which is 1 itself. So now this is in the form of a plus b whole square, a square cos square theta plus b square sin square theta plus 2, a is cos theta into b is sin theta is equal to 1 square is 1. Alright. Now we know that sin square theta plus cos square theta is equal to 1. That is the trigonometrical identity. Sin square theta plus cos square theta is equal to 1. So from this we can write sin square theta is equal to 1 minus cos square theta, or cos square theta is equal to 1 minus sin square theta. So I am replacing this cos square theta with 1 minus sin square theta plus sin square theta with 1 minus cos square theta plus 2 cos theta into sin theta, right as it is equal to 1. Now this 1 plus 1 is 2, 2 minus sin square theta minus cos square theta plus 2 cos theta into sin theta is equal to 1. Now if we take minus common from these three terms, we'll get sin square theta plus cos square theta minus 2 sin theta cos theta sin theta is equal to 1, right? Now can we write this as, this is in the form of a square plus b square minus 2ab, right? But we want cos theta minus sin theta whole square. So let's say our cos is a square, a, and sin is b. Then a square plus b square minus 2ab. So this is in the form of a minus b whole square, where a is cos and b is sin theta. So we can write 2 minus of cos theta minus sin theta whole square is equal to 1. That will be minus of cos theta minus sin theta whole square is equal to 1 minus 2 is minus 1. Minus minus gets cancelled. We have cos theta minus sin theta whole square is equal to 1. Since cos theta minus sin theta whole square is equal to 1, so we can write cos theta minus sin theta is equal to root 1, which is root 1 is plus or minus 1, because 1 square is also 1, minus 1 whole square is also 1, hence proved. Hope this is clear. We have just taken the given data cos theta plus sin theta is equal to 1, then we did square on both sides, then expanded a plus b whole square, then replaced cos square theta with sin square 1 minus sin square theta and sin square theta with 1 minus cos square theta. Then if we rearrange it, we got 2 minus of cos theta minus sin theta whole square is equal to 1. Transpose it and we have our required answer. Hope this is clear. Okay, let's see the next question. Question number 30. Part A. The minute hand of a wall clock is 18 cm long. Find the area of the face of the clock described by the minute hand in 35 minutes. Let's see. Okay, we have a wall clock. So let us, okay, this is 12. Okay, I'm just drawing a rough clock. Okay, now the minute hand of a clock is 18 centimeter long. Let us say initially the minute hand is at 1. So this length is given as 18 centimeters. Find the area of the face of the clock. Describe the minute hand in 35 minutes. That means it will reach, this has to reach till here. Right? So this is 35 minutes. So that we need to find this area. Right? So this is nothing but the sector of a circle. Right? We know that area of the sector is theta by 360 into pi r square. Now we know that, so here the radius of the sector is nothing but the length of the minute hand, which is 18 centimeters. So we know radius is 18 centimeters. What we need to know is the sector angle. What is the center angle here? Theta. So we need to know this angle here. Right? See here, we know that the complete angle is 360 degrees. Right? That means in 1 minute, so for actually 60 minutes, for complete is one complete rotation 60 minutes. For 60 minutes, the angle described is 360 degrees. So for 1 minute, the angle described would be 360 by 60, which is 6 minutes. Right? But we want the angle described for 35 minutes. So it will be 35 into 6, which is 210 degrees. This is what we need first. Right? So angle described by the wall clock in 35 minutes will be 210 degrees. Now we have theta, we have the radius as 18 centimeters. We just need to substitute the values. Okay, let's write down. So length of the minute hand which is in fact radius r is equal to 18 centimeters, and angle described in 35 minutes is equal to, we got as 210 degrees. Then angle swept by the minute hand, so the area swept by the minute hand or area described by the minute hand, anything is fine. Area described by the minute hand in 35 minutes is equal to theta by 360 into pi r square. Now substitute the values. Our theta is 210 by 360 into pi, we can take it as 22 by 7 since nothing has been mentioned, into r square is 18 into 18. Now simplify this. You can cancel 0, 0, 7 can cancel here 3 times, can cancel 18 here 2 times, then we can cancel 2 here 11 times. So it will be 3 times 18, 54 into 11, which is 594 square centimeters. Right? Here if you want to know what is a shortcut, there is a shortcut to multiply any number with 11. See here, I am multiplying 54 into 11. You just write the extreme digits. It is not only for 2 digits, it can be for any number of digits. Write the extreme digits. Here we have only 2 digits of 5, 4, given space in between, and add these two numbers. So 5 plus 4 is 9. So it will be 594 square centimeters. What if we get some carry? Let us say we need to multiply 68 into 11. Write 6, 8. Now when you add 6 plus 8, we get 14. But we should not add a 6, 1, 4, which is wrong. We have to write 4. So 6, 8, write 4, and the remaining one we need to carry over to the 6, which will be plus 1. So it will be 748. Alright. Okay. Hope this is clear. This part. Basically, we need to find the area of the face of the clock, discard the minute hand in 35 minutes. So basically, this is the area of the sector. We know that theta area of the sector formula is theta by 360 into pi r square. Here we know everything except theta. So that is the angle made by the minute hand in 35 minutes, right? So we need to find what is the angle now. For whole 60 minutes, we know that is 360 degrees. So for 1 minute, the angle discard will be 6 degrees. We need for 35 minutes. So just multiply by 35. So 35 into 6 is 210 degrees. We have theta, we have r. Our r is length of the minute hand. So just substitute, we get our required answer. Next, look part B. AB is a chord of a circle centered at O such that angle AOB is 60 degrees. If OA is 14 centimeters, then find the area of the minor segment. Take root 3 is equal to 1.73. So we need to find area of the minor segment. So we need to find area of this part. Right? So how do we get this area? So this is nothing but area of the total sector AOB. So area of this part, which is the pink part, right? Area of the sector AOB minus area of the triangle AOB will give this part, right? So if we subtract, so area of minor segment, we get area of minor segment is equal to area of sector AOB minus area of this triangle AOB, right? First write down that area of the minor segment, area of the minor segment is equal to area of sector AOB minus area of triangle AOB. Area of triangle AOB, right? So we know what is the center angle here. The sector angle is 60 degrees, which is given angle AOB is equal to 60 degrees. And in the previous question also we discussed area of a sector is theta by 360 into pi r square. We have theta is 60 by 360 into pi into r square. We have OA is 14 centimeters. That means, so this is 14. OB is also 14, which is radius. 14 into 14, right? Then area of the triangle. So how do you find area of this triangle? Since this AOB is 60 degrees, we know OA and OB are radii of the circle. That means the opposite angles have to be equal. Since the angles of opposite equal sides are equal, so then since this is 60, remaining two angles should be 120. So 120 by 2. That means each angle will be 60 degrees here also. So it turn out to be an equilateral triangle. So we know area of an equilateral triangle is root 3 by 4 a square. So we need to know these two formulas in order to solve this question, right? Let's just substitute the values. We have either you can separately find area of sector, then area of triangle, then substitute back, or we can directly do it. I am substituting it directly. Area of sector theta by 360 into pi r square minus area of triangle is root 3 by 4 a square, where a is the side of the triangle, here r is the radius of the circle. We have theta is 60 by 360 into pi 22 by 7 into r square 14 into 14 minus root 3. In question it is going to take root 3 value is 1.73 by 4 into a square will be 14 into 14. 14 into 14. We can simplify this now. Cancel 0, 0, 6 can go here 6 times. We can cancel 7 here 2 times. Then it would be 2 times 14, 28. 28 into 2, 56. I am writing this 56 into 11 so that I can apply 11 table shortcut here. Minus, or I can also cancel 3 also here, 2 also. I can still cancel. 2 goes here 3 times, here 11 times. Right? So this will be 28 into 11, which will be 2, 8. Then add 8 plus 2, 10. So we need to add 1 here. So it will be 308. 308 by 3 minus, we can cancel here 2 times, here 7 times, again 2 here 7 times. So 1.73 into 49. This is 84.77, and this will be 3 goes here 10 times, 3 2s are 6, 6 minus 84.77. So we get 102.66 minus 84.77. 7 9 15 minus 7, 8 11 minus 4 7, 9 minus will be 17.89 square centimeters. This should be our answer, right? So nothing, we just need to know that area of this segment is area of the total sector AOB minus area of this triangle. Then we get our required area. We need to know what is the formula for area of the sector and what is the formula for area of the triangle. So here we know that since the center angle is 60 degrees, since OA and OB are rated, the base angles also have to be equal. So it has become an equilateral triangle. So area of an equilateral triangle is root 3 by 4a square. We are just substituting all the values and simplify it, and we get 17.89 square centimeters. Okay then. Remaining question, there is only one question left. We'll do that in the next video. Thank you.